Good evening. Right, so guys, I apologize profusely. I don't know what is happening, but just to pretend let us start. Sincere apologies. Just dismissed us. I was in class before, then it kicked me out, and then I had a difficulty getting back in. So I think it's fine. Where it is that we are, and let's just move. I need to move into something new. Um, hoping that you've got an opportunity to look at the work that we did on Tuesday it was. And then tonight, we're going to be moving into Unit 2 that speaks about continuity and differentiability. We're going to be looking at continuity and differentiability. It sounds big. You just want some bright when they say it. Really, all that we learned in Unit 1 about limits is going to be used in Unit 2 for continuity and differentiability. It is one of those interesting units. It's one of those interesting units, not difficult. However, the intuitive approach is going to be applied to one of the areas in the mathematics here. One of the things that I'll say to you is that for the exam, you get a question about anywhere between 8 marks and 12 marks. Right? Now, if you can get a question for 12 marks and you understand that topic pretty well, and you get a 12 out of 12, you must pass the course then. Of course, you can do some other questions here, but getting 12 out of 20 for one question is setting you up nicely to pass in the course. So I'm going to ask that you be somewhat sit back. I hope you guys are relaxed as we embark on a new era for mathematics tonight. But before I do, and while this thing comes up, are there any questions of me? Were you able to complete the question or no? What was it again? Somebody had a question about question 4A. Very well that you. Somebody was asking, whoever it was, are you better able I think it was usually, are you better able to understand the area now, or is it that it's still a little fuzzy in your headspace? That's a question. Hello, somebody, anybody?
So what did you say, sir?
And I'm saying, I think Andre was asking a question on Tuesday about something that I explained. So I'm asking the class if the explanation is now understood.
Sir, I wasn't here on Tuesday. For Unit 1, there are some things I'm a bit fuzzy on, but I think that's on my own terms with practicing a little bit more, and then it will become clearer to me because I can't really pinpoint to say R is what I'm not clear on.
All right, we have to have a look. I'm going to ask that you go through the recordings over this week.
I intend.
Yeah, man. And then now you can just write down those areas that you are comfortable with. And then we can take it to the session on choose that activities? No, that so it is that we can go through. So I depend on you to do that for me, all right?
Okay, sir.
Good job. Now, are there any other comments or questions? Speak now or forever hold your peace. I am about to begin our unit 2 on continuity and differentiability. Very important. I'm seeing a new face in the class. Can you, are you in the right class?
So you ask another question just now. I've been struggling to get my cursor on the right screen.
Yeah, no, it's just that I saw a strange face, a strange name in my class. But Sabrina, you have not been the whole of last week. I don't see Sabrina. What does that mean? Sabrina? Miss Rita, good afternoon.
Hey, call me. I have a good night.
What are you doing?
I'm okay. I can hardly hear what you're saying, so I have to put the laptop close to my ears.
Okay. Alright, I'm hoping
Repeat, sir?
that it will improve somewhat because I am at my maximum.
I don't hear you.
Is there anybody else hearing me, or you're also struggling to hear what I'm saying? Okay.
I'm hearing you clearly, sir.
Okay, thanks, Bill. Talia, turn up your microphone, please. All right, so let's go. Oh, incidentally, Sabrina was calling me here. Cool. So the statement of conditions for continuity. For a function to be continuous, f of a must exist. For a function to be continuous, f of a must exist. I must have a point so that when I substitute that point into the function, I get a result. F of a must exist. Second point is the limit as x tends to a, and up the top is a plus. That plus is called a superscript of f of x. It's going to be the limit as a tends as x tends to a to the negative sign of f of x. And that is going to be equals to the limit as x tends to a of f of x. And then the final one is f of a, therefore is going to be equals to the limit as x tends to a of f of x. Those are three conditions that you must know. Can you, well, you will agree when I say f of a must exist. So the function, you must have a function in order to check for continuity. True or false?
Sir, sir,
I'm hearing the issue.
can you check your audio? Because most of what you're saying on my end is coming a bit muffled. I'm hearing you, but I'm not sure if it's my end, whether it is too loud or what, but you're coming in a bit muffled. I'm not
Same,
sure.
sir. Like, I can hardly hear what you're saying.
So I'm hearing what you're saying, but it's like there's too much bass.
It's all about the text, about the text, about the text. All right. Let me know how it sounds now, please. If you are hearing it clearly, can you raise your hand for me, please?
Hearing you, sir.
All right. Thank you. AC, Talia, and Dre. What about the rest of you? Not hearing me? You can lower your hands. Okay, Tristan, I see your hand. Okay, Sherry, I see your hand. Simon, you're not hearing me? Okay, thanks, Simon. Oliver, Sabrina. All right. Now that you all are hearing me, let's go again. So I'm saying to the function f of a must exist. F of a must exist. And I'm also saying number two is very important. Number two is what it is that we have been doing. Number two is what it is that we have been doing. The limit as x tends to a to the plus. So what is a to the plus? Can anybody tell me what? Hold on. Undo. I need to be. I'm trying to do. I can do this. Okay. Okay. Yeah. I want you to look at the screen for me, please. The limit as x tends to a to the plus, a raised to the plus sign of f of x. What do you think that one is asking us to do? I've done this with you.
Sir, there's a black screen in front of whatever it is that you're showing.
Yeah, you are correct. So it's gone. The limit as x. Oh. I was trying to save something for you, but it wasn't saved. The limit, Dre, as x tends to a superscript plus of f of x. What is that asking us to do? We've done it in class. We've never described it like this before, but I want to use your, extrapolate from what it is that we've done. What do you think this is? I notice that I have also the limit as x tends to a, and then I put to the negative, and then I put a function. Could be the same function, could be a different function, whatever it is. What do you think I'm talking about here? Anybody? Anybody who gets this right on the way in passing the exam?
So is it describing the forms like if it's undefined or indeterminate?
Okay, okay. But before we get to the indeterminate form, what do we need to do first?
Now substitute x into x.
Substitute the value for x, sir.
Okay, fair enough. So we substitute the value for it. When we're looking at the intuitive method, tell me what it is if I did. When I look at the intuitive method, what it is if I did? Mm-hmm. Okay, somebody please.
So we look at the function to see when x tend to approaching 1.
Yeah, but what else should we do? Approaching one, so here.
Then we'd substitute the value of x.
No, before you do that, please, what else you do?
Say that again, sir?
Before you do that part, what else do you do?
The division aspect, I guess.
Before you do that part, what else you do? Somebody here for okay? I just want to show you a connection, you know.
So you mean where we estimate the left and the right?
Yeah.
Approaching 1.
It's approaching. So what do you think the limit as x tends to a to the plus? What do you think that plus is?
Adding 1.
No, think about it. What do you think the minus is?
The negative versus the positive.
What
The left
represents it?
versus the right.
Very good. Which is the
Left
left?
side versus the right hand side. The
Very
left
good.
would be the negative.
And the
The right would be the positive.
go through. Go right through. All right. So the x tending to a to the plus is actually speaking about the left hand, the right hand side. It's actually speaking about the right hand side. Let me see if I can type that for you. Right. So tell me what it is that we did. Remember, when we looked at the left hand side and we looked at the right hand side, we normally value for right up. What is the right up talking about? Can anybody remember that little statement that we normally write? What is the statement? What the statement normally says?
Whether or not it's of good behavior, sir?
Yeah, but I want the whole statement.
We would say that is of a good behavior since the limit approaches whatever number it would approach from the left or from the right hand side.
Look at Look at rule number 2 and tell me if you think that's what that statement is saying. The limit as x tends to a superscript plus is the limit as x tends to a from the right hand side. We also now need to investigate the limit as x tends to a from the left hand side. So which is why I have x tending to a to the minus. If both limits are tending to the same something, what do we say? The limit is of
Good behavior.
Good behavior.
it's of a good behavior, and that's why outside here so now I just have the limit as x tends to a of f of x exists. All right. So we have done that. We have done that. We have done that from day one by saying to you, the limit on the left hand side must be equal to the limit on the right hand side. If both limits are equal, then we say that the limit is of a good behavior and the limit exists. Anybody ever hear me say that before?
Yes, sir.
Right. So it's just a new convention that you're seeing. Don't stress out yourself over it. It's just a new convention you see. What's the new convention? It says the limit as x tends to a to the plus of f of x. Relax your little selves. Relax yourselves. Because if you look at it, you recognize it's the same thing. If both limits are equal, the limit as x tends to plus a plus to the limit as x tends to b minus. If both solutions are the same, then it means that the limit exists and we are for good behavior. The limit exists and we are for good behavior. The last one now says f of a is going to be equals to the said limit. The limit as x tends to a of f of x equals 0. What I have done is to give you an opportunity to read.
Sir, can you read back what question B is saying? Is that
No,
saying-
the limit as x tends to a to the right hand side is going to be equals to the limit as x tends to a from the left hand side, but this time I'm not calling RHS and LHS. I am speaking from to the minus and to the plus. To the minus and to the plus. Fair enough?
Sir?
I'm asking you, does that answer your question?
Yes.
Alright.
Yes, sir. Yes, sir.
Good job. Is there another question from the class before I move on?
No, sir.
What understand value?
No, sir.
Who said that now a while ago? Is that Oliver?
Sounds like him.
Yeah, but Oliver long time I not see you, Papa. Long time
Over
I not
there.
see you.
Them over there.
We never there Tuesday. I mean, I never seen you Thursday either. Tell truth.
I was here, man.
Okay. So we're talking about the statement. Hey, we never normally take so much time for this, you know. To the point you're not the left hand side, right hand side, but anyway, come. In order for the statement of continuity to take effect, there are 3 steps. F of A must exist. F of the function must exist. You have to be able to substitute values in the function to test whether or not the left hand side is going to be equal to the right. If I give it a function as a constant, you can't work out anything so similar to that. Even though when it says but I'm saying to the limit as x tends to a superscript plus of the same function f of x is equals to all of that. And then when you look at the limit as x tends to negative a to the negative sign, it means that it's moving to the left hand side. Are you following what I'm saying, right?
Yes, sir, following.
Okay, good. All right. So we say that it's of a good behavior since the left hand side is equal to the right hand side, and because the left hand side is equal to the right hand side, we therefore say the limit as x tends to a of a function must exist. And then finally, the function f of a is going to be equal to the limit as x tends to a of f of x. Sometimes in the exam they ask you to write any two of the three rules. Guys,
So, sir,
yes, ma'am.
question. These are questions are the formula A, B, and C.
Those are the conditions for continuity to occur. If those conditions occur, then the function is continuous and differentiable. If those three conditions are met, the function is continuous and differentiable.
What do you mean when I say differentiable?
We're getting there, Nikki. Very good question, but we're going to get there.
Sir,
Yes, ma'am.
does these conditions have anything to do with line graph, the x and y axis?
Not at all.
Okay.
Can I tell a secret? A baby something that one day. Big school you them know. In their grade 6, them their K5 or grade 1 work. Grade 6 today. Alright? So let's go. I was gonna say something before Nikki unmuted. I'm not getting the energy from the class. I'm really not getting the energy at all from the class. And forgive me for saying this, but I don't know if anybody else sees it, but the level of participation is not there, it's absent. What is the problem?
Muy altine. Muy cansada.
No comprende, señorita.
I think sir understand what I just said.
English, por favor. Sir, remember it's a math class and it's online, so most of us probably don't understand. So we're going to be quiet to listen attentively. So
that one is a lie, Nikki, because if you're not understanding, that's the time I expect you to say, sir. This is just like go tell you, sir, someone, and I'm just very concerned about the class. I mean, I'm just going to be very frank and honest. I'm very concerned to the point where it was recommended that we may need to move this class to face to face.
was recommended to move the class to what?
From online to a face to face because you guys not learning.
What is sir?
I would agree, but there'll be some little drawback for that because honestly, sir, I'm catching up, trying to understand from the beginning while you're moving on, and I don't want to be left behind. So I am the slow but I am at a slow bunch in the class.
Yeah, but and I don't have a problem in that, Nikki. But if every class time I'm gonna come and tell you that I'm not getting the energy from the class, I really am not getting the energy. You guys are losing up because I have to suck the classes up. I mean, to be honest with you, let me tell you where my headspace is going. Right about now, I am at the point of saying, let us just call it a night now, and you guys go and catch up on the things that you would have done before by listening to the recording so will come afresh on Tuesday. And this is when it hurt us. It's when it hurt us one because I didn't remember that the class time changed on Tuesday, so we missed about an hour on Tuesday. And now we're going to be missing about an hour and a half today. But there is no way I can honestly, in clear conscience, continue doing this. You know why? I've been teaching up my heart and my soul, and then if I will come back and reteach it. And I'm not about that. You guys are just not participating. I am very disappointed. I'm very disturbed about what you're here to ask me. When I say very disturbed, I am extremely disturbed about it. What say
What is
you?
it that you require was?
Um, AC, to be honest with you, respectfully, this has nothing to do with you because you are one of those students in the class that communicate with me. And let me just say it now. The last couple of times you were unable to join the class, I don't hear a voice saying, yes, sir, I understand, or I don't hear a voice to say, sir, I don't understand. And it is very concerning. To be honest with you,
Okay, sir.
it's very concerning to the point, AC, where I may tell you, I don't want to hear from you, not in a bad way, if you understand what I'm saying. But there are others up in the class. From even I'm coming and I'm calling Sabrina, and Sabrina is not responding to me. Now, what kind of foolishness is that? I'm saying hello, Sabrina, earlier on in the class, and no response. I don't know if Sabrina is in class. I don't know if I know what Simon's voice sound like. Tristan, hardly speaking class. Oliver is here, run again. So the ones that really speak in class is Dre, AC, Chev, and Nikki. Those voices I can hear. Tonight is Stanley's first class. Can't work. There are no 1, 2, 3, 4, 5, 6, 7, 8. There are no 9 of you. It started off with about 5. There are no 9 of you. And I'm telling you guys, I'm not prepared to go through the semester. I'm not fighting with a sword. I'm not prepared to go through the semester with this. Even true.
Sir, if you're gonna change class, just bring me with you. And if you're not bringing me with you, don't give us report. Thank you.
No, well, you see, the truth of the matter is, I don't even know your star. I have to have a conversation with this family on this matter because this is definitely not working out. And I don't want nobody to say, I don't like the matter, so I'm not talking. You need to get in a headspace. I need to know what it is that you know so that I can say, yes, you have a part, or I can say, no, I'm a psycho. No, man, get away. I'm not getting it from you. And I don't want nobody to tell me, so they can't learn online, because there are so many other students that did it before you. You too can do it for yourselves. Talk to me now, let me know what I need to do. Talk to me, let me know what I need to do.
So moving to face may be a challenge because having the previous class online, then leaving from home to go back on the road.
So most of us having challenge getting to class early online as well. It's a good idea, but it's also a bad situation gonna happen. Because some of us leave work late, some of us at work while you're having class. Speaking for myself, don't know if other persons are encountering the same. So I don't know.
Anybody else? What do I do?
Sir, for me,
Mm-hmm.
the face to face, I think personally it would work out better for me. But also, I live way all the way in Spanish Town, so the traveling would be a bit challenging for me. That's just my take on it.
So you're saying you're
And
not.
rushing to get like class on time,
Mm-hmm.
especially during this time, like when rain is falling and a lot of traffic.
Mm-hmm.
So,
And Oliver is in St. Answer.
oh yeah, I read the message. See that?
But there's a message in it, that?
Yes, sir.
Yeah, but Oliver not talk to me. That's the problem. Oliver not talking to me. That's the problem. And I disagree with you, Oliver. That you
Sir,
have
Oliver,
to.
type in the chat.
Yeah, man. I see that, but I'm just saying I disagree when you say that I have to get a few examples in first before. Um, and Oliver, you know, I'm gonna make a recommendation. Because not only your background is noisy, Nicole's background is also noisy. But I'm gonna make a recommendation. I'm not teaching anyone to fail, of course. I'm not teaching anyone of you to fail, of course. You have to find that space that is going to be conducive for work. You must find that space. If you have one bathroom, you can lock up in the bathroom. When I say, I know everybody has a bathroom, but if you have a bathroom of your own, you can lock yourself away in the bathroom. If it means you have to go sit down on your porch, or your balcony, or under one tree, one go do it. All one chair outside and do it, but make sure you put on your box break, but no one will catch dengue. But you have to go find that space. You have to find that space. Because me now go come to class and I go stress out myself. Because when I do that, and then when I look at the exam and say, sir, I couldn't do the question, then I know something I teach it. No, man, it can't work, man. It can't work, guys. It is totally unacceptable for and also unfair um for me to find stuff and or maybe not find but to try to bring across the idea in a way that is digestible in bite-sized pieces. That's the point I'm trying to make. I'm trying to find stuff in the bite-sized pieces and then I am just here talking to myself. I know it is unfortunate if if one of you if AC asks me a question and I ignore the question and AC says, sir, how what and I ignore the question, I'm sure the next time she's gonna write to say, Mr. Shan is not responding to me in class. I'm asking questions and he's ignoring me. Who do I call to say that the
Sir,
students are ignoring? Yes, mommy.
if you ignore me, I'll say, sir, I'm not paying you to ignore me. So please
AC,
answer my question.
amen, sir. So what must I
And
say to you now, AC? Tell me what I'm supposed to say to you.
stop wasting my time and respond to me and tell me if you understand or you don't understand, or I will
Check,
think you're not here and being receptive to what I'm teaching.
check the recordings.
Because, sir, I remember you said, we laugh at each other. We
Mm-hmm.
make mistakes together. So if you
Absolutely.
don't understand, I'm willing to explain.
Absolutely. Absolutely. This is our safe space. I have created a safe space for the class, but it can't right now. There are four voices, distinct voices of them here. Students, it is no, it is not working out. This is what I'm gonna do. I'm not going to go up to 10 o'clock tonight. I'm not going to do this to myself. I love me. So this is what I'm going to do. I'm going to go over the statements for the condition for continuity. I'm going to go to those three equations once more. And I'm going to do two examples with you on it. Because the honest truth is, there is a piecewise function that I needed to teach you tonight. It really doesn't make sense I do this. It honestly does not make sense if I do it. Because
Let us see how we catch on the two examples then, and then you know if we can move on from there.
so do I have a commitment that if when I'm going through the question and I ask a question that I get a response from the students in the class? That's all I'm asking for.
Yes, sir.
All right, thank you.
Yes, sir.
Let's look this. So let us look at the statement for conditions for continuity, of conditions for continuity. The function must exist. F of A must exist. If I cannot make a substitution into the function, it means it don't exist because I have a constant. So F of A must exist. A is my point. I'm substituting that point into the function. And the value of F of A is going to exist. Right? So we say that, there is a value. So if I give you x squared plus 4x plus 2, it means that when I substitute A into it, I'm going to get a value out for the function. Right? I have my inputs, and then I have several inputs, and then I'm going to have one single output. All right? Now, for the second one, it says the limit as x tends to a plus of f of a, or of f of x is going to be equal to the limit as x tends to a to the minus of f of x. What that is translating to mean is that the limit from the left-hand side must be equal to the limit from the right-hand side. And if it does, then we say that the function is of a good behavior and the limit exists. All right? So that's exactly what we're talking about here. The limit as x tends to 8 superscript plus of f of x must be equal to the limit as x tends to a minus of the same f of x. And if that is the case, we say the limit is of a good function, a good behavior, since the left-hand side is equal to the right-hand side. So therefore, x over all of that, f of x, the limit as x tends to a of f of x is going to exist. And then finally, f of a is going to be equal to the limit as x tends to a of f of x. Do you recognize that what is in A and B are combined to give C? F of A exists. The limit as x tends to a of f of x exists. That means f of A is equal to all of this. So these two conditions flow into the creation of a new condition. So it's like I'm saying to you, Mary is related to John, but John is related to Susan. In our Jamaican context, Susan and the other person say, hey, me, are you related? Not necessarily. Not necessarily. But we're saying that the conditions in A, f of A must exist. So that means that f of A is this f of A here. And this condition down here says the limit as x tends to a of f of x exists. So we know that once these two are equal, that the limit is going to exist. You see all of this? Wow. Rough, you know? Rough.
What is that black square there?
I'm actually trying to color code something, Papa. So to see if you can.
Sir, you just lost me. I'm trying to make notes. You're saying all of f of a exists into. Can you hear me?
I can hear you, but can you step away from that noise?
Sorry, I'm in the living room, so people
Tell
pass.
tell them to come out of the living room.
All right. Sir, yeah, I got what you start moving fast after you're saying all of f of a exists into f of a equal moving to the that screen is blocking.
Hold on, my love. Hold on. I'm trying to color code some stuff. Yeah, you said that I lost it. Where now?
All right, so I heard the part when you said all of f of a exists in the function f of a moving to the limit of x. Then you started some things and I got lost.
All right, look at it, Nikki. You must have a bank account. You must have a bank account. The bank account must exist. Talk true. You not follow me?
Yeah.
You must put in money in the account, and the same amount of money you put in the account is that amount of money you have to withdraw from the account in order to keep the account active. In order for you to keep the account active, because it exists. You add money to the account first, then you're able to draw from the account. So the same amount of money you add to the account and the same amount of money you can draw from the account. You can't draw more. You can draw less. But in this case, the account exists. F of A is your bank account. There is one. You're in other work, and the work say, well, you do stuff, we're going to lodge your pay to the account C tier. The limit as extends to A to the positive superscript. You add money to your account. And as the days go by, the weeks go by, the months go by, you are now subtracting money from the account. So you're looking at the right hand side, then you're on the left hand side, and then now you're going to combine. So if the right hand side is equal to the left hand side, you say that the limit exists. And you can say further that the limit as x tends to a of f of x exists. And then somebody say, but you know, a long time you never do want to do something. But look at what is going to happen. Seeing that these two independent equations stand alone, you see this f of a that is in green, see it so at it this. You see this limit as x tends to a of f of x so on the other one, see it at it this. So we're saying that since this condition holds true, and this condition holds this one true, it means that the two conditions must be equal. Anybody in this class has a stepbrother or stepsister?
No, sir.
No, sir.
No, okay. Andre and I call ourselves related. I don't want to work with me. Andre and I call ourselves half brothers. Also no. My birth mother is in a relationship with Andre's birth father. Both of them come together under the same roof. Both of them call the offspring to come and live together because we are one big family. Is it safe for me to say that Andre and I are brothers?
No, sir.
Why not?
No.
Why not?
Kanye and brother may live under the same roof, but they're not brothers, not related.
But my mother and father married.
Not by blood.
Sure, we're under the same roof, so come together as one family.
You think
Even
so?
though we're not biologically related, we're related.
You think so?
Not by blood.
Not by
Not by blood.
but
Not
by
by blood.
relations.
All right. So it are the same something when you can talk about and say, yeah, we're related. That's so. The one year in a A and the one year in a B are angle and triangle, and we're going to combine the two of them for you C. So I'm saying that f of A exists. You have a bank account. You're going
So,
to add
sir,
money to. Go ahead.
so f of A would be the household. Okay.
And that must exist. Then what I'm doing is looking to the left hand side and looking to the right hand side to see if when I evaluate those two, I'm going to get this outside here, so. And then I know it also exists. And then this is my final condition. My final condition says f of A is going to be equal to the limit as x tends to A of f of x. You know to say the answer of yes, sir. I don't know, so. And the answer to the long something also, so. Boom. See this, so. And the answer to the one here, so. Tell me so don't say that now.
Yes, sir.
Yes, sir.
Alright. Nikki. Nicole?
Sir?
Or you see? Yeah, you get that now?
Sir, my son was kind of distract me just as you were saying something. I'm so sorry. So I missed that last thing you said. I'm so sorry.
Alright, so one, that's fine. So one final time. So I'm saying to you that if f of A exists, f of A exists. F of A is a real something, it's not an imaginary something, or a real something. Then we're going to try out what happened in a B. We're going to use the calculations because I'm going to say, yo, we're going to look to see what happened on the right hand side. We get the answer, then we'll put it down. And then we're going to look to see what is happening on the left hand side. We get the answer, we'll put it down. Hold on, sir. The same answer I get for the left hand side, the same answer I get for the right hand side. So yeah, that's what I was expecting. So boom. I can say that f of A is equal to the limit as x tends to A of f of x. And then the question asks me to find the value of x for which so if you look at an example here, we need to find the value of x for which that function, this rational function, is discontinuous. And discontinuity is also to say that it is undefined. Yes, please.
Sir, again, I can't tell what is in my space, but me try to substitute it. All right, so we know f of A is it must be there. So in order to get the limit of f approaching that, hold on, baby. So some calc is either minus or add like substitution to remove the limit approaching f of x equal from the right hand side. So you're gonna minus that from the limit of approaching, am I saying it right? Limit approaching f of x from the left hand side, and whatever it equals to, you substitute it for the limit of f of x that which exists, so that remain. That's what my brain comes up with in trying to understand, to ensure that I understand. So I can say a lot of madness.
No, and as I said before, I don't know why I can laugh after you.
Let me see what you do when you put numbers there. Probably I will better understand. Go move on. Let me see what you put numbers there.
So I had a conversation with you before to say that a zero cannot exist in a denominator. When a zero exists in a denominator, what do we say about the function?
Undefined.
Very good. It is undefined. So whenever you get a question like this, the function is undefined and the denominator is equal to zero every single time, barring none. So we say that a function is undefined when the denominator is equal to zero. A zero cannot exist in the denominator. So what we need to do, that denominator, x squared plus 9x plus 17, must be factorized. so that we can isolate the term that is causing the function, the term or terms causing the function to go to an undefined state. So therefore, x squared plus 9x plus 20 is going to be equal to 0. So we need to factorize that. We need to factorize that. And then remember that now the rule says we multiply the coefficient of x squared by the constant. What is the coefficient of x squared in this question?
20.
Nope. Check again. The coefficient of x squared.
1.
Numero
Same,
uno.
sir.
Numero uno. Right. What is the constant now?
20.
20. Very good. Very good.
Wait, sir, repeat.
The coefficient of x squared is the number in front of x squared. And the constant term is negative 10.
The constant is the number without the x. The one that stands by itself.
Ah, remember you said that some time ago, and I said to you that I'm going to come back to you. You were asked to write it down.
Mm-hmm.
All right, so I'm still going to come back to you with that one.
And then the x squared tell you, there's one number before it, so we automatically assume it's
Hold up. Okay.
because x by 1 would give you the same value.
Right. You are fully correct, except when you say there's no number in front of it. Because if there's no number in front of that, that would be the x squared would have gone, I just have 9x plus 20. So there's always a number in front of it. So when you're not seeing a numeral in front of a thing, always assume that there's a 1 there. Always. All right, so what I'm going to do is to multiply 1 times 20, and I'm going to get 20. I need two numbers. When multiplied together, what gives me 20, but when added, it gives me a 9x. What number is it in here?
The 5 and the 4.
5 and 4. But 5x times 4 is equals to 28. Sounds fabulous to me. All right. So if you look carefully, you see that I'm breaking up my 9x into 5x and 4x. So I now have x squared plus 5x plus 4x. And I put it in blue so that you can see it. So I'm going to be grouping. Remember, sir, so when you group in, you can put them two for something in one bracket. So we have x squared plus 5x. See, just a boom. And then this plus sign, I'm going to leave it out every single time. And it's going to have 4x plus 20 right here. So no, because it's an equation. And we we are finding the point of discontinuity. We have to set it equal to 0 or no, let me not give it an or. But yes, we have to factorize the function, and the function is going to be equal to 0 because I can only solve and factorize. I can only solve. So in a group, what is common between x squared and 5x?
X.
What is left?
X plus 5.
Good job. And you can see that 4 is common. And the x plus 5 is common also now for both terms. Right? And because the x plus 5 is common to both, I'm going to factor it out. Factoring out the x plus 5, I'm going to be left with x plus 4 equals 0. So either this x plus 4 is equal to 0 or the x plus 5 equals 0. So when I transpose, I'm going to get x equals to 4 or x equals to 5. And those are the two numbers that will make my function undefined. How you know that, sir? Let's just try x equals
Plug them
negative,
in.
plug them in. And I plug it in. Negative 4 squares is negative 4 times negative 4, and negative 4 times negative 4 is positive 16. 9 times negative 4 is negative 28. Let me say 28, what is it? 4 9 is 36. Let me say 28. 4 9 is 36. And then I'm going to have 20. And then now, positive 16 plus 20 is going to be 36. 36 minus 36 is equal to 0. Uh-oh, I have 1 over 0. Is that undefined?
Yes, it
Yes,
is
sir.
undefined.
Okay. 1 over 0. Is it indeterminate?
No, sir.
Why?
Because it's already undefined. I don't think there is a case where it can be both. Is there?
Okay. Why is it not indeterminate?
Because the indeterminate would have both denominator and numerator as 0. And then it would mean that we need to factorize, which we just factorized.
Okay, so thank you, AC, for now giving me the correct answer. You are right on point. If it is indeterminate, you'll have 0 over 0. Not 1 over 0 or 1 over 1. 0 over 0. Understood?
Yes, sir.
Yes.
Hmm.
Sir, I understand that.
Sir?
Sir,
Uh-huh.
I understand that part, but it's the one
Uh-huh.
that the bigger thing at the top kind of look a lot complex.
Nikki,
Yes, sir.
is the other bag of something here? Is factorization.
So that my understand clear. So the ABC now A B and C statements at the top
Sir?
I'm coming
was
to
what
Italia.
give me problem.
Mm-hmm.
Because I was trying to reason out what it means or what you're trying to understand, but I understand that which you just did.
Yeah, but also, and I'm happy for that, but also, what I was giving you there is a condition for continuity. You remember you have conditions for everything. You have condition for marriage, you have condition for have baby, you have condition for how you come in here or you relax here, you have condition for how you eat because you can't eat the food and then go lay down and sleep. You have to have acid indigestion. So there are conditions for everything. So I'm saying to you, and hear me out. They can ask you for 3 marks to state the conditions. They can ask you to state the conditions. Either, well, you don't have to even say that. But yeah, so you need to know what are the conditions f of a must exist. The limit from the left hand side must be equal to the limit from the right hand side for the limit to exist. So x tends to a, x tends to 3 to the right, x tends to 3 to the left. Both of them are equal, so I'll say the limit as x tends to 3. Because I don't have to, look here. You notice right here, so I don't have any sign, either plus or minus, which is right here, so. Because from a test already, one time, from the right, and I tested from the left, and I told them come out to be the same something, hey, the answer right. So what is going to kill you for this question? Oh, let me finish it. So either x plus 4 equals 0 or x plus 5 equals 0. See it right here? So I'm isolating this 4. So I'm going to have x is equal to negative 4. Here. X equals to negative 4. And then something with, and so forth and so on. And so forth and so on. So the aim of this thing is to practice on your factorization. This is what I want you to do for me in class. Now, on your mark, get set, go. I'm going to hydrate myself a little, step in a little too, while you work on that question. Soon come. All right. I don't think you heard anything I said a while ago because I'm looking up and recognize I was muted. All right. So let me go again. So I was talking just now, and I don't. None of you have heard me because I was muted. This is to find the values of x for which f of x is equal to 1 over x squared plus 15x plus 56 is discontinuous. So the question is telling us that it's discontinuous. And the question is asking us now, hey, find those points of discontinuity. Find those points for discontinuity.
Sorry, breaking up.
Mhm. All right, do me a favor.
Sure, so we must find those points of discontinuity, or that's what the question is asking.
Both of them are saying the same thing. The question is asking that and me wanting to do it. Start now for me, please. That's some come. We finish that one there?
No, sir.
We kind of get something I'm not sure if you're right. No?
Say it again, Papa.
We kind of get something I'm not sure if you're right.
Say me again.
All right. Let me look back on the paper now. I have 1 over x squared plus 15x plus 56. Then the factors I'm ending up with is 8x and 7x. Then we end up with 1 over x bracket 8x 8 plus x close bracket plus 7 open bracket x plus 8 close bracket. Then we'll come down and then we end up with two brackets. We get x plus 8 in one, x plus 7 in one, and then we equate them to 0. And we get minus 8 and minus 7. But I don't know if I'm right.
And I think that was on top. That's all I want to do from you. Because you are correct about 99% of it. And I guess it's just a slip of the tongue because I only heard it once. You said could be twice. You said you're carrying down the 1 over the x squared plus 7x plus 8x plus 56. No, you're not carrying 1 over. Instead of 1 over the function, it is only the denominator you're working on. So you're only evaluating the denominator and trying not to
Okay.
get. You see what I'm
Not
saying?
to touch the one any at all.
Yeah. So look at my example up top. My example up top wasn't concerned with what is in the numerator. Look at what it says.
Oh yes, you dismiss it for real. Yes.
Absolutely.
Yes.
But outside of that, proud of you. Keep up the good work. Let's go. Let me go
Okay.
through this. Let me go through this example here. See here? So the function is undefined when the denominator is equal to 0. Think about that. Every single time that is going to be the case. The function is going to be undefined when the function is undefined. The function is undefined when the denominator is equal to 0 every single time. So I'm going to let the function be equals to something, and I'm going to work it. So yes, I'm going to say x squared plus 15x plus 56. So we're going to factorize. The coefficient of x squared is 1. And I'm multiplying that by my constant term, which is 56. I need two numbers. When multiplied together, we're given 56 and 72, whatever it is. I need something to give me 56. So what is going to happen is I'm going to prime factorize, and when I get my factors, or if I don't even have to prime factorize, because the truth of the matter is you can see this. 7 times 8 is 56, but 7 plus 8 is equal to 15. So those fit my factors. All right? And then I'm going to do the substitution. I'm going to group. When I group, I'm going to have my first two in a set of parentheses. So it's not by chance. So this x squared plus 7x is going to be here. But sir, when I did the question, I put 8x squared plus 8x first. Not a problem. Still get the same answer. Not a problem. Still get the same answer. All right. Now, when I group, I'm always leaving out the middle sign here, and then I'm grouping the last two terms. What is common between x squared and 7x?
X.
And I take it out. So I'm going to have x plus 7 left. What is common between 8 and 56?
7.
8.
All right. 8. So because 8 times 7 is 56. But do you not recognize that this x plus 7 is the same x plus 7 right here? So therefore my x plus 7
Yes.
times x plus 8 is my answer. But I'm not finished yet. Because we need to tell them now. When I do the transposition, x is equal to negative 7, x is equal to negative 8. And those answers in blue tells me that I will have solved my value. So what it says, the question says determine the value or values of x for which the function is undefined. And then you go to proof. Look at it and tell me if you are in agreement.
Look at it and tell you what?
If you're in agreement,
Yes, sir.
sure. All right, I'm going to do one more. Not
Agreement to what, sir?
what I have on the screen. If you understand what I have on the screen.
Okay.
Sir, I do, but I need to work more on my factorization.
And I'm happy that you recognize where the limitations are. Do that one for me, please. I'm giving you 4 minutes. Start now, please.
Yeah. I'm a factorization need work.
I think I'm finished there.
Finish? Anybody?
Yes, sir.
What's the answer?
Sir,
Implies that x equal minus 3 or x equal 2.
Sir, what?
Mm-hmm.
Nobody not hear me?
Yeah, we hear you.
Just hearing it, Talia.
Oliver, what do you say?
And I was saying that I was hearing her.
Mm-mm,
Me end up, me end up.
You get the answer?
Oh, yeah, man, we get the answer, but we get something different. We don't know who right now.
So maybe what do you think?
We get x minus 6 and x plus 1.
Okay. Who else?
all right, so let me factorize this.
Sir,
Well,
Tristan, Sam get 1.
Okay, thanks. Somebody says coming in a while. Trevor, that's you?
yes, sir.
Mm-hmm.
Hey, so we realize some can use 3 and 2. So we use 1 and 6.
Why can't you 3 and 2?
So we can multiply.
Mm-hmm.
We're supposed to get negative 6.
Mm-hmm.
And so we multiply 2 number, one of them have to be negative. And when you add them, you're supposed to get 5.
Mm-hmm.
So if you add negative 3 and 2, you now get 5.
Very good deduction, Papi. Proud of you. Very, very good deduction. I have heard the correct answer, but I don't know who it is.
All you
But the
have to
correct. All right. Yes, AC. Oliver is correct. I'm going to project the solution. Well,
Sir, I
hopefully did
forgot
it.
more or less that he was correct. I realized what I did wrong.
Look. So, Chevy Chase say, huh? Can't you answer? Because if one of the numbers is negative, 32 is negative. Negative 2 times 3 is indeed negative 6. But when I add negative 2 to positive 3, we get 1. That can't work. And then flip it. And say, but that's still negative 1, it can't work. And then hear what Oliver said. But we know so that makes sense. X a positive 5, positive 6, and Y a negative 1. And when we multiply positive 6 with negative 1, I will get negative 6. And add them, they will subtract 0 on the one on the right. Alright? So that's what it is that you want to do. But as I told you, I'm not going to teach you until later tonight. What I want you to do is to practice on your factorization. I want you
Yeah,
to practice on your
that is
factorization.
the key.
That is the key. That is the key.
Sir, honestly, for real. Because you see me, whenever I get this thing wrong. Come and use the 3
Sir.
and the 2. Come and say the 3 multiplied by the 2 that give
I
us
know to
6.
get money outside.
Mhm.
Sir, the one use 1 and 5.
What kind of 1, what kind of 5?
Sir, I think it's negative 1 because you know multiply negative 1 times negative 6 you get back the 6, negative 6. Negative 1 times negative 6 you get back 6.
Mm-mm.
Hold on, I get positive 6.
Negative.
1 times 6.
Okay.
And then when you do that with the add it, you get 5.
Correct. Alright. I'm going to end here. Students, if I'm eating a call, Sabrina now, no, Sabrina now answer me.
Can you
I'm
scroll down for
eating.
me, please, just a bit? Thank you.
No problem. I want you to do me a favor, students.
Yes, sir. What is that favor?
I want a brand new set of students from next week. Tuesday, what's with him? So we can run through. We missed 2.5 hours now in total. No, not 2.5. Yeah, 42 hours in total now. We need to make up. I don't want you guys to be so relaxed in class. I mean, and guess what? If when I come to class and I have issues and I get hurt, me, I'm not feel good and irritated, I say, oh no, no. Because my not feeling well don't affect whether or not I teach me. I have to turn up. I must turn up. Right? So I want to turn up for the next week. These are times. I'm going to see if I can generate some more questions on this and send off for you so that we can have more practice on our own.
Thank you very much.
Okay, sir. And next time you come into class,
Uh-huh.
when you're eating, you share what you're eating. I realize you eat every class or drink every class, and you don't say,
Nuts for the works.
you don't say,
can send
"Una
it on nuts for
thirsty."
AC, leave me alone. Leave me alone, AC. I know
You don't
AC.
say,
I
"Una
want
thirsty," or "Una hungry." All right, sir.
A bag of chickens next time. All right, then. All the
All
best.
right.
Take care, guys. Cool.
Have a good night.
You too, love.